Hello, everyone, and welcome back again to our channel, Tutoring Made Easy. Please, if it's your first time coming in contact with our channel, we want you to do us a favor by subscribing, liking this video, and sharing to as many people as possible. The goal of this channel is to bring tutoring help to as many people around the world. We began with our math journey, but we have, you know, paused it a little while and begun the probability journey. And in this journey, the goal is to make probability as easy and comfortable as possible. If you have specific topics that you want us to treat on, feel free to drop it in the comment section below, and we'll be more than willing to do those videos for you as well. In today's video, we are going to continue with probability. We looked at the definition or the understanding of probability. We also looked at the axioms or the properties of probability. And today we are going to be looking at certain types of experiment and trials. Yes. Now, you remember we mentioned that if you toss a coin, if we just have a coin, a single coin, if you have a single coin, right? If you have a single coin and that single coin has two outcomes, it has only two outcomes. And because it has only two outcomes, which is it's either a head or a tail, either a head or a tail. Because it's a single coin, and because that means we can only perform one trial or one experiment. It's just a single experiment, which is just a coin, not two coins, but only one coin. And because a single coin or one trial has two outcomes, we said that is called a Bernoulli, a Bernoulli trial or experiment, a Bernoulli trial or experiment. So we know that a Bernoulli trial or experiment is any experiment or only is a one trial experiment, and that one trial experiment has two outcomes. One trial experiment has two outcomes, then it's a Bernoulli trial. However, if we should toss several coins, if we are tossing several coins together at the same time, even though each of them has two outcomes, we are doing these many trials at the same time, we call that a binomial trial. But today we're just going to focus for now on the single trial, and then we will continue from there. So let's imagine that we have an experiment. We are conducting a single experiment, an experiment. It is only one trial, one experiment, or only one trial. And that trial, that experiment is tossing a single coin. Tossing a single coin. That is our single experiment or one trial that we are performing, is to toss a coin. Now, because of that, we're going to have some outcomes. The outcomes, the possible outcomes of this experiment of one trial tossing a single coin is that we will only have a head or a tail. When we toss a single coin, it's either a head that can show up or a tail that can also show up. Now, there are similar types of trials like that, like the trial of a human being. It's either the human being is dead or the human being is alive. It's a Bernoulli trial. If you have a machine, it's either the machine is working or the machine is broken down. That is a single trial, and the outcomes is only two. So if you have one single trial, one experiment, and the outcomes is two, is known as the Bernoulli trial. I hope that is clear. Now we have something called events. An event. So let's imagine that an event. We want to find out the event that there's a head. What is the head? What's the head? So now we can be asked that we should look for the probability. What is the probability? The probability, it can be a head or tail. Okay, the event can be a head or tail, but the probability, if we are being asked to look for the probability of a tail, what we should find the probability that is of a tail. We know the probability formula. Remember, we said the probability formula. We said the probability formula. We said that the probability of an event is equal to the number of that event. Don't forget that the number of that event divided by the total outcomes. divided by the total outcomes. That's the probability of the event, and that's the probability formula. Now we have a question before us. We are being asked to find the probability of a tail. So if we are going to use the probability formula, it's going to be the number. It's going to be the number of tails. Is the number of tails divided by the total outcomes. The total outcomes. Now, what is the number of tails in the experiment? The experiment that we are having is a single coin. The outcomes are only two, a head or a tail. Now, the probability of a tail, the number of tail. How many tails do we have in these outcomes? It's only one. So write one. There's only one tail. So one tail divided by the total outcome. The outcomes are one and two. There are two outcomes, so divided by two. So therefore, the probability of a tail is 1 over 2 or 0.5, and it satisfies the properties of probability, where probability cannot be less than 0, it cannot be negative, but it also cannot be more than 1, and 0.5 falls in that particular category. Now let's move on. Let's imagine for a second that we are conducting another experiment. And in this experiment, we are going to toss a coin. We are going to toss a coin. We are going to toss a coin 2 times. Okay, let's toss a coin 3 times. Okay, let's turn a coin. We are going to toss this coin 3 times. We're going to toss it 3 times. And when we do that, our outcomes, our possible outcomes, how do we know our possible outcomes? Remember, because a single trial or a single toss, okay, because a single trial, single toss, the formula is going to give us an outcome into bracket to the power of what? The number of experiment. Okay? And this same formula can be written as the outcomes into bracket to the power or exponent of what? The number of trials. I hope you can see how important mathematics is in probability, because this thing that we are writing all the way here is under the topic known as indices and exponents. Indices and exponents. So it's important for us to have strong math background so that we can be able to, be comfortable while doing our probability. Now, to plug in this formula, we know that the total outcomes, like we said, is the what? Is the outcomes, the number of outcomes for one trial outcome, okay, all to the power of what? The number of trial. So here, the one trial outcome of a coin, if you pick only one coin, the outcome of that coin is two. We only have two outcomes. And then we are going to have to the power of what? The number of trials. How many times are we performing this experiment? This experiment, we are tossing the coin 3 times. So it's going to be exponent 3. And that's going to give us 2 times 2 times 2. And then that eventually is going to give us this, and this is giving us 4 times 2, and we get what? 8. So there are 8 possible outcomes. How are we going to list it? Let's list the possible outcomes. Okay, list the possible total outcomes. There are 8 outcomes. All right. So we're going to list it. So the first possible thing is that we're going to have a head, and a tail, and a head. So the first, when we toss it the first time, let me take my time. Let's imagine for a second that when we toss this coin the first time, a head shows up. We toss it the second time, another head shows up. We toss it the third time, a head shows up. Or it could be possible that the first toss is a head, second is a head, the third one is a tail. Or the first toss was a head, the second toss was a tail, the third toss was also a tail. All right. Or the first toss is a tail, second is a tail, third is also what? A tail. So far we have 4 outcomes, but we need 4 more to complete the 8 tosses. The next one could be that the first one was a tail, or the second one was a tail, and then the third one was a head. Or it could be that the first one was a tail, second one was a head, third one was also a head. Or the first was a tail, second was a head, third was a tail. Or the first was a head, second was a tail, third was a head. And that completes the possible outcomes. Now we are going to solve some problems together. Let's imagine that we're being asked to look for the probability that there were three heads. The probability that there were three heads. And remember, the formula is that the number of heads, right? The number of three heads, because we are looking for the event. The event is three heads. So the number of three heads divided by the total outcomes. Divided by the total outcomes. So the number of three heads is only one here. There's only one that has three heads. So it's one divided by the total outcomes, which is 8. And then that ends our probability for finding the three heads. Now, what about the probability that there's only one head? Oh, sorry, there are two heads. Let's say the probability of two heads. We have to look for the number of two heads divided by the total outcomes. Divided by the total outcomes. Divided by the total outcomes. And to do that, the number of two heads we can see is one is here, another two heads is there, and then another one is also here. So there are three two heads divided by the total outcome, which is 8. Okay. Now, if the question says, can you find the probability of at least one tail, at least one tail, it means that probability of more than one tail. It means probability of at least one, right? It means probability of what? One tail or more tails. One tail or more tails. It could be one tail or more tails. So now we are getting the number of more than one tail, including one itself, right? Or more than one tail, but one is included, more than one tail, with one tail being included, because at least means that from one going. They didn't say more than one tail. Divided by total outcomes. Now the number of more than one tail, if you look at more than one tail, there's one tail here. There's two tails here, so it qualifies. There's three tails here, more than one tail. There's two tails here. There's one tail here. There's two tails here. There's one tail here. This is not part of it. So there are 7 possible outcomes divided by the total number of outcomes. And then we are going to bring our discussion here to a close. But remember, we said that when you conduct an experiment, if you conduct one single experiment, okay, and the outcomes is 2, then it's what? A Bernoulli trial. Don't forget that. It's a Bernoulli trial. Okay? And if you do this Bernoulli trial several times, so we have repeating the experiment, the same experiment, the experiment that has only 2 outcomes. If you repeat this experiment, it is known as a binomial trial. A binomial trial. So don't forget that. Please don't forget that. A single experiment with 2 outcomes is known as a Bernoulli trial. If you repeat that trial, it is known as a binomial trial. Also, do not forget a probability formula. The probability formula says the probability of an event. It says that the probability of an event is the number of that event divided by the total outcome. So don't forget this formula as well. It's very important. The probability of an event is equal to the number of events divided by the total outcomes. The other thing that you shouldn't forget is to find the number of outcomes, total outcomes. How do we know the total outcomes? It is the outcome of a single trial. Outcome of one trial, into parentheses, exponent what? The number of trials. Exponent the number of trials. If you haven't yet subscribed to our channel, please do us a favor by subscribing. This way you help us grow so we can be able to help as many people as possible. If you're already a subscriber, we want to use this opportunity to say thank you to you. We are grateful that you are growing our channel with us together. If you have specific topics you want us to treat, please drop it in the comment section below, and we're more than willing to do a video on that for you. But at this moment, we are going to end our experiment on tossing a coin here, and we'll come back again to continue a different concept in probability. Take care and bye.